So now we're going to take a look at some final drive systems that are off-road. A final drive is still a final drive, but there's some variations between on-road and off-road. Usually because the amount of torque that's required to move some of this equipment. So the gear reduction inside the final drives are usually a lot more. So we're going to take a look at how some of these are set up. So number one, we can have some of our machines that have an engine for each track drive. So from our engines, we go through a transmission which are synchronized into our crown and pinion, which goes out to our final drive. Now we're going to take a look at how some of these final drives are set up and configured. We've talked in earlier videos about how our outboard planetaries are set up. Now, again, a lot of these are set up exactly the same, where our sun gear is our input, our output is our planetary carrier, and our internal gear or ring gear is held as part of the case. Now, we've also discussed at the very beginning is how many planet carriers we have and how we can increase the amount of output to each of the planet carriers. If we increase the amount of planet carriers, we can spread that load over more planet carriers. So if we take a look at some of this big off-highway equipment, so for instance at a mine, one of the problems we have is ripping the differentials out because the amount of torque that the engine can put out. So what they'll do is they'll run chains on some of these machines to allow it to slip, because if it can't slip, the differentials are going to get ripped out. There's just too much torque. When we're dealing with, smaller vehicles, like this is a 35-ton cat wagon or a 50-ton cat wagon, again, they're going to have outboard planetaries. The speed isn't the greatest, but the ability to move large amount of load is phenomenal. Off-highway fire trucks. Now, again, at airports, they not only have to run on the runways, but if an airplane goes off runway, they have to be able to get there. So they'll have outboard planetaries on these. Scrapers, again, non-driving axles there, but we're going to have outboard planetaries there. So when I'm scraping, again, I need to pull a lot of weight. So these outboard planetaries have enough of a gear reduction that we can. The other thing we can look at is double planetary gear sets, where one planetary gear set runs into a second planetary gear set. And again, it's like any double gear ratio. It increases the amount of torque we can have, and with that we can also run a smaller shaft on our input. So notice the amount of planetary gears in there to help distribute the load throughout the whole gear set. Another planetary gear set, again, we can go with a smaller input shaft. Now, getting away from the planetary gear sets themselves and taking a look at off our transmission, our pinion is going to run a crown gear. Now, in a normal machine, an older one, what we have is off of our input, we run our crown gear. Our crown gear is going to run a spur gear, where our spur gear is going to run a bull gear, and off of our bull gear, we're going to run a planetary gear set. So this is a double reduction, but actually it's three, because we also have a gear reduction here. So we can run with huge amounts of torque to be able to move material. If we take a look at how some of the older equipment was set up, where we had just a single reduction final drive, And again, I'm not including our crown and pinion as a gear reduction. It's just our single reduction final drive. These final drives used to be they're quite large because we can get the amount of torque out of them. But then when they went to this style here with a planetary gear set, we could increase the amount of output torque just through the gearing. For instance, let's take a look at a grader, a simple grader. So in a grader, this is our chain case. So on our chain case, we have one wheel on each side. And how this is set up is out through our final drive. We're going to have inside our chain case, we're going to run two chains, one for the front drive hub and one for the rear drive hub. And we'll run the same on both sides, but we're still going to run a differential in the middle to allow torque to go to each of the drive axles. So if we take a look. So here's our transmission, here's our output, here's our gears, and our shaft that runs out to our chain cases. I got a better picture here of how it's set up. Now, there's a housing here that is bolted to this. So again, one of the things we have to pay attention to when we're working on grader chains. Now, inside a differential, let's just say we're looking at a highway truck and we have different sized tires. What happens inside the differential when we go around a corner? Well, one wheel has to travel further than the other. But in a chain case, on one side, we don't have different sized tires. And our chains are driving equally on the front and the back. So what's going to happen as we go around a corner, the differential internally will have to take up for that. But our chains, front and back, they cannot because it's a solid link. So if we're doing a lot of excessive cornering or sharp cornering in a grader, you'll notice the tires will start to skip because the way the gearing is through the chain case. So our input from our differential comes into a planetary gear set for a gear reduction, and it goes out to our two drive sprockets. Again, one drive sprocket goes to the front, one drive sprocket goes to the back. And like we talked about before, is with chains, there's no give. As the chains wear out, so if I'm taking a look at the chains in a chain case, as the chains start to wear, if we're going to change one chain, we have to change both. And if it gets to that point, we should be taking a look at the other side also. So how do we measure chains? Well, if you remember from first year in a chain case, what we're going to do is we're going to take the chain and we're going to hang it, and we're going to put a big weight at the bottom to make sure that there's no oil in there and see how much it's stretched. And what we don't want to do is we don't want to run these chains up on the very top of the sprocket because it's going to break the teeth off. So over a period of time, as we do a lot of cornering or side loading, these chains are going to stretch. So we got to pay attention to how much stretch these chains have. Six wheels, outboard planetaries, mounted final drive units. Again, they're to move large amounts of weight. Not a lot of speed in some of these. So taking a look at, again, articulating machines, all of these have final drives in them. On the older machines, the final drives, again, if you remember, there was a spur gear that ran a bull gear. This is the bull gear. So again, we have a smaller spur gear driving this bigger gear here, and these had no planetaries in them. So one of the things we had to ensure is that they were full of oil. So making sure that the oil level to where it was and checking the magnetic plugs. And down below here is a drain plug. So making sure that all of the components were getting lubrication. When we take a look at, again, how the bull gear and the spur gear were running, now if you remember back from when we first started, we have straight cut gears. We have no axial loading on these. These are all radial loading, so they have to be supported on both sides by bearings. When we start getting into high drive cats, so a high drive, again, we got to really be careful when we're working on equipment like this that we block the tracks, because if we take this cover off, there's 3 bolts on here, remove this cover and pull the sun gear out, there's nothing to stop this machine from rolling away. So always, anytime we're working on any heavy equipment, ground the equipment. Put the blade down, block the tracks, and if you got to remove the sun gear, just be aware that if we disconnect this track, there's nothing to stop it from rolling. So just be aware of that. When we get into, for instance, excavators, they'll have a planetary final drive, but they may be run by a hydraulic motor. So the hydraulic motor is going to run the sun gear again, ring gear is going to be held, and planet carrier is going to be our output. Checking oil levels in, for instance, a high drive cat. If you take a look at the planet carrier cover, it will have a line on there. So you line that up, and that's how you check your oil levels. When you're taking a look at differentials, again, some of these you can get into the back to check your final drives. Again, just be careful when you're working on these things that you follow the safety procedures. Some of these, when the box comes down, there's a cable on the back. It hooks into here. So if you're working up in the front on the drive shaft, the box can't come down. Anytime we're working on articulating machines, number 1 is use the safety locks. A pinch hazard, just stay away from those when you're working on drive shafts. Make sure you use a safety lock in the pins. And that's it for the final video on this section.